Good morning everyone, and welcome to this skills video for the Room 2003 science classes regarding writing chemical equations from verbal descriptions of chemical reactions. What I use is a kind of a four-step process where it involves four components, and I'm going to step aside for a moment. There's four listed on the board, and I'll pause for a moment and allow you to read through these. But these are the four steps or components that are involved when I work through this process of writing chemical equations from the verbal descriptions. All right, from this list, this numbered list, you see that number 2 is about using PubChem. If I do not know a chemical formula or an element symbol, I use PubChem to look them up, and I will show a PubChem demo in a separate video. For the purposes here, though, we are just going to focus on the processes involved in step 1 and in step 3 and 4. So please refer back or stay tuned for that PubChem video. So with that introduction to the process I use, let's look at two examples. Right, here's the first example, and what it says is solid mercury 2 oxide decomposes to produce liquid mercury metal and gaseous oxygen. Again, the first step in the process for me is to identify the products and reactants, or reactants and products, in the verbal description. And what I look for is the arrow. The arrow in a chemical equation shows us where the reactants are and the products. The convention in chemistry is always to write from reactants to products. So the products come out of the reaction, they're on the pointed side of the arrow. The reactants go into the reaction, they're on the dull side or the back side of the arrow. So one of the first things I do to identify products and reactants is to look for the arrow. And in this case, the arrow is indicated by the words "to produce." And so what that indicates to us is that mercury 2 oxide reacts to produce metal, liquid mercury and gaseous oxygen. So I'm going to diagram the sentence with the arrow. Now that I have my arrow, I know that the reactants are on the left or on the dull side of the arrow and the products are on the right. What I look for to identify reactants and products, if I don't already recognize them, is just kind of the weird phrases. So in this case, mercury 2 oxide stands out at me on the left side of the arrow as more than likely the chemical, and in this case it is. I understand the word solid and decompose, but mercury 2 oxide is the strange one. So I'm going to circle it and label it. It's on the left side of the arrow, so it is the reactant. Now on the right side of the arrow, or on the other side of the point of the arrow, I see mercury, and since I see mercury 2 oxide left, then mercury, it makes sense, is one of the other chemicals, and I already know that oxygen is one of the chemicals, is a chemical, so I'm going to circle those and label them with a P for product. And again, I know they're products because they are on the pointed end, pointed side of the arrow there to the right. Well, in this case, it gives us the phases, so I'm going to go ahead and label the phases with the subscripts. We know it's solid mercury 2 oxide, liquid mercury metal, and gaseous oxygen. So now with this diagram of the sentence, I have everything I need to write the equation. So let's go ahead and write it then. Again, if I don't know a chemical, I'm going to use PubChem to look it up. In this case, mercury 2 oxide, I used PubChem to look that up and get the chemical formula of big H, little g, big O. And that is a compound, so everything's written together. Mercury, because I knew this, I knew what mercury's element symbol was. And oxygen, I know what it is because in chemical reactions, if it just states oxygen, what it's referring to is atmospheric oxygen, which is O2 gas. There are 2 or 3 things that chemicals that we will assume we know unless the description tells us differently. Oxygen refers to O2 gas, atmospheric oxygen. Hydrogen means H2 gas, and carbon dioxide means CO2 gas. So unless the problem tells us differently, we will assume to begin with those 3. Oxygen means O2 gas, hydrogen means H2 gas, and carbon dioxide means CO2 gas. All right, with that, let me erase this one and we'll do another one. All right, here is our second example. Solid carbon reacts with gaseous oxygen to produce gaseous carbon dioxide. So this problem tells us gaseous oxygen, gaseous carbon dioxide. But if it left those words out and it said solid carbon reacts with oxygen to produce carbon dioxide, we would assume that oxygen means O2 gas and CO2 means, or carbon dioxide means CO2 gas. And again, with this verbal problem, notice to produce in the problem. So that tells us that the arrow is pointing this direction again. So let's look for the reactants on the left, products on the right. In this case, we have 2 reactants, 1 product. In the previous case, we had 1 reactant, 2 products. Let's go ahead and label the phase subscripts. Now we have everything we need to write the equation. We have all the chemical formulas, we have the arrow, we know the reactants and products, and we have the phase subscript. So let's write it. Okay, that's really all there is to it. The thing that probably takes a little bit of the most getting used to, well, 2 things. 1, recognizing those strange things are probably the chemicals, and then 2, identifying whether the arrow, it's written so the arrow is moving to the right, or if they flipped it and they give you the products first. When we write the chemical equation, though, the chemistry convention is we always write reactants first, arrow, products on the right side. All right, that's all there is to it. I'm going to step out of the way for just a moment and show this example, and then I'll be back to close the video. That's it for the skills video, writing chemical equations from the verbal descriptions of the equations. As always, until next time, be safe and do science.